Hello Year 3 and welcome to our maths lesson. For today we're going to be comparing fractions with the same denominator. But first is your do now. As always, recommend you pause when the do now comes on screen so you can complete it and then you'll be able to check it afterwards. But please remember to upload your do nows to Seesaw. Okay, so here is your do now and pause the video. Excellent, and now here is your opportunity to check them. Those answers, making sure that you've completed the relevant band. If you've completed a band, you can always move into another one. Challenge yourselves. And please remember to upload your do nows to Seesaw. So today we are going to be comparing fractions with the same denominator. So to be successful, we're going to need to be able to identify the features of a fraction. We're going to be using place value, so our knowledge of place value, to identify greater and smaller numbers, and then we're going to be comparing fractions using the correct comparison sign. So let's look at today's star words. Fraction, numerator, vinculum, denominator, compare, and remember we've got our comparison sign, so we've got less than, equal to, greater than. So let's have a look at some examples of this as a bit of a refresher. Greater than, less than, and equal to. Now, if you remember in year 2 we looked at this and we had a friend, we had our hungry crocodile. I wonder if you can remember what the rule was with the hungry crocodile. The hungry crocodile always wants to eat the bigger number. So I'm just going to put our signs up here. The hungry crocodile always wants to eat the bigger number. So let's look at this example. 18, is it bigger than, greater than, less than, smaller than, or equal to 81? So looking at our tens column first, because that's going to be the quickest way to identify whether a number is greater or smaller depending on the number of tens. So in 18 we only have 1 10. In 81 we have 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. Therefore 18 is less than 81. 18 is less than 81. So I'm going to be drawing my less than symbol, because if you think about it, is my hungry crocodile going to want to eat 18 or 81? It's going to want to eat 81. Then let's look at another example. 23 and 13. 23 and 13. So how many tens do we have in 23? We have 1, 2. How many tens do we have in 13? We just have 1. 2 tens is larger than 1 10. So 23 is greater than, it's a bigger number than 13. My hungry crocodile's going to want to eat 23. Imagine it's 23 donuts rather than 13 donuts. Let's have a look at another example. Oh, this is interesting. 5 and 9. 5 and 9. Is 5 greater than, less than, or equal to 9? Let's have a look using our place value. There are how many ones in 5? There are 5. 1, 2, 3, 4, 5. How many ones are there in 9? There's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just make that one a 1, 9. So I can see that there are more ones in 9 than there are in 5. Which one's my hungry crocodile going to want to eat? The larger one. 5 donuts or 9 donuts? He's going to want to eat 9 donuts, so it's less than. So remember, crocodile always wants to eat the larger number. Okay, back to fractions. Back to fractions. Quick look at this. Have a quick pause and have a quick think. Which of these shapes can represent fractions with the same denominator. Remember, denominator is the number of parts a shape or a part is divided into, the whole. So pause this now. And then when you're ready, we'll have a look at the answers. Okay, which of these shapes can represent the same denominator? So we're going to check. So 2 of these shapes, C and G, represent a half because they're divided into 2 equal parts. Thirds, we have B, D, and H because they're divided into 3 equal parts. And finally, A, E, and F are divided into quarters because they have 4 equal parts. But what's different about all these shapes is they all have different numerators shaded. And that is what we are going to look at, how we compare fractions with the same denominator. So here I have a line, and on each of these lines I want to represent 2 fractions. My top line I'm going to represent 4/10, and my bottom line I'm going to represent 7/10. I'm going to use this to compare the size of these 2 fractions, and then we can think about sentences about how we can to describe their size. So I'm going to use cubes to represent my fractions. So I want to show 4/10. My whole is my 10. This line has on 10 squares. I'm going to represent 4 cubes. I'm going to use cubes to represent each tenth. 1/10, 2/10, 3/10, 4/10. Next, I'm going to show 7/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. So I've represented my fractions using the cubes for us to have a quick, easy comparison. So in this case, we're checking, and both fractions are divided into the same amount. So the whole is the same, and they're divided into equal parts. Each of these squares is worth 1/10. So we can see here at the top that 4 parts of 10 are represented in these cubes. 4 parts of 10, which is my whole, are represented in these cubes. In this fraction, 7 parts of 10 are represented in these cubes. Therefore, this representation shows more cubes than that one. As you can see, because if this was my whole, this is my whole, 7 parts of it are shown with cubes. 7 parts would be shaded. Here, 4 parts are shown with cubes. 4 parts would be shaded. So looking at here, 4/10 is smaller than 7/10. So if we were to write it as our fraction sentence using our crocodile, 4/10 is less than 7/10. 4/10 is less than 7/10. We can also revise it as a greater than sentence. So 7/10 is greater than 4/10. You can see how this representation could show either one of these statements. Let's look at a few more examples. So here we have a square. This square is divided into a number of equal parts. First of all, we want to count how many equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this shape is divided into 9 equal parts. I want to shade 1/3 and also 2/3 on another shape. So first of all, I need to work out how much I need to shade. So I know my whole is 9. My whole is 9. Remember, to find out the fraction of an amount, we take our whole, which is 9 squares here, and divide it by our denominator. So 9 divided by 3, how many, if I divide 9 into groups of 3. How many do I have in each group? I have 3. So I'm going to shade 3 squares. Looking at my other shape, I want to shade 2/3. So I know that 1/3 of 9 is equal to 3. To find out 2/3, I just need to multiply the amount in 1/3 by 2. My numerator, we've done this all before. So 3 times 2 is equal to 6. Well done. So I'm going to colour 6 squares. I know you can all probably colour much neater than I can. So what we are going to look at now is which shape is greater, which fraction is greater. With this diagram, we have a very, very clear idea because we can see visually that more squares are shaded on this square than in that square. So we can say that 2/3 is greater than 1/3. So to do that, remember, our hungry crocodile is going to want to eat 2/3. There's more of these squares for him to eat. What statement in a sentence could we write to compare these fractions? Have a think. What statement could we write to compare these fractions? We could say 1/3 is less than 2/3. We could also say 2/3 is more than 1/3. Both of these statements mean exactly the same thing. We're just using less than in one and we're using greater than in another. Let's apply what we've learned so far to some word problems. Which would you prefer? A cake has 8 slices in total. You can either have 2/4 of the cake or 3/4 of the cake. So here is our steps to success. So we need to first of all identify and represent the whole. I'm going to show you on the whiteboard using cubes. So identify and represent the whole. Our whole is going to be 8. So I'm going to draw, we're going to imagine it's like a brownie or something. I don't know about you, but it's nearly lunchtime for me. It's going to make me quite hungry. So here are my 2 representations of my cake. So this is cake 1 and this is cake 2. Each cake is divided into 8 pieces. Each cake is divided into 8 pieces. To start off, I want to have a look and see how many pieces do I have to make 1/4? How many pieces do I need to select to make 1/4? So I'm going to divide 8, which is my whole, by my numerator that I'm looking for, which is quarters. 8 divided by 4, well, we know that's split in half. We're dividing 8 into 4 separate pieces. Let's do a quick 1, 2, 3, 4, 5, 6, 7, 8. That means in each group there are going to be 2. So I'm looking for, in piece number 1, I'm looking for 2/4. In piece number 2, I'm looking for 3/4. So piece number 1. In piece number 1, I'm looking for 2/4. So I'm going to be timesing my numerator by how many, I know I need 2, each 1/4 is 2. So, but I need 2/4, so I'm going to multiply my numerator by the amount in each quarter. So 2 times 2 is equal to 4. So I'm going to put my cubes here just to show again how this works. Then I'm going to be looking at my next amount, which is 3/4. So I'm going to multiply 2 by 3. 2 times 3 is 6. Not sure why that took so long. Because I know I have 3 parts out of 4 shaded. So I need 3 times 2, because 1/4 is equal to 2. There's 1/4, 2/4, 3/4. So I want to know which one is greater, or which one would I prefer? Well, it all depends how much cake you want, whether you want lots of cake or whether you want only a small bit of cake. But looking here, we can say that we have got more parts shaded or selected in 3/4. 3/4 is larger. Remember, a hungry crocodile always wants to eat the larger number than 2/4. 2/4 is smaller than 3/4. Spot the deliberate mistake. It should be the other way around. Because remember, our hungry crocodile is going to want to eat more cake. So 3/4 is larger than 2/4. 2/4 is smaller than 3/4. Which would you prefer? As I said, depends if you want more cake or not cake. I think I'm going to go for 3/4 of the cake. Thank you very much. Right. Let's do another one. There are 20 pages in the comic. Ridwan reads 4/5 of the comic and Sayar reads 2/5. Who has read more? So identify and represent the whole is our first step to success. Here you can see that I've represented my whole using a diagram, using a picture, and I've split it into 5 because I know that my denominator here is 5 and I am splitting in my 20 into 5. I'm splitting in my shape into 5. So I can see, looking here, I can use this as a picture to check, and then I'll also calculate the amount. So my denominator, so Ridwan has read 4, so I'm going to shape 4/5 of my shape, and then Sayar's read 2/5. I'm going to shade 2. I can see here that looking at it visually that 4/5 is larger than 2/5. But let's check with the amount of pages. So I'm going to, looking at my denominator, I'm going to split 20 between 5 equal groups. So that means I'm going to be doing, let's just go back to our board to do the calculation. I am going to be doing 20 divided by 5. 20 divided by 5. 20 divided by 5. How many groups? How many are in each group? If I divide 20 divided by 5, I can use my hands, I can skip count, or I can just use my mental arithmetic, because we should know this by now. It's 4, because 4 times 5 is equal to 20. I want to find 4/5 of 20 and 2/5 of 20s. I can see visually that one is larger than the other, but I want to double check with my numbers. So remember, fractions of amount, divide by the bottom. We've already divided by the denominator. We get the answer 4. Times by the top. 4 times 4 is equal to 16. 2 times 2/5. Divide by the bottom. We've already done that. 20 divided by 5 is equal to 4. Multiply by the top, the numerator, 2 times 4 is equal to 8. Therefore, looking at here, I can see that 16 is a larger number than 8 because there is one 10 in 16 and there are no 10s in 8. So, who has read more? Who has read more? Looking here, we've got 16 pages compared to 8. And we can also see that represented on our diagram. So Ridwan has read more. I'm just going to underline Ridwan's name. Good. So let's do a comparison. So here we're looking at which is larger, 3/6 of 12 or 2/6 of 12. So we have got a visual representation of our whole. So we need to identify and represent the whole. We've done that in this case. We've done our diagram. We've done our diagram. We could count cubes, we could count sweets, we could count coins, marbles, whatever you have to make this easy for you. Then we need to look at the denominator. We need to split the denominator into this many equal groups. So I need to split 12 into 6 equal groups. So I'm going to draw my equal groups. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I've selected my equal groups. Then I need to, so I've done that. So I need to look at my numerator. What is the total value of these groups? So into 6 equal groups, I need to look at how many is 12 if I split it between 6 equal groups. I can obviously do 12 times 12 divided by 6 to help us, but we can also look in each group. We've got 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 12 divided by 6. If I split 12 in between 6 equal groups, I have two in that equal group. So this first one is looking for 3/6, which means I'm looking for 3 equal groups. So I can shade in 3 equal groups here to help us. Or as well as another representation, I can multiply the amount in each equal group by the numerator, just like we were doing with fractions of amounts. See, it all comes together. 3 times 6, 3 times 2 is equal to 6. Let's have a look at the other one. Let's look at here, 2/6 of 12. I'm going to shade in 2 equal groups, and I can do 2 times 2 is equal to 4. I can visually see that 3/6 is larger than 2/6, and I've done my maths to prove it. 3/6 or 2/6. So 3/6 is greater than 2/6. So my hungry crocodile would rather eat 3/6 of 12 muffins than 2/6 of 12 muffins. So you need to we're comparing which one is larger. If that's what the question asks us, greater. If it asks for a smaller, it will be lesser, smaller. With these kind of comparison questions, you need to make sure that you're reading the question carefully. Right. So this is time for your independent task. So you have 2 pages, because on one page we're going to be just doing a comparison table where you need to write a word statement and also use your equivalence signs. So you've got visual representations. You need to then draw them. Remember, try and use a ruler if you can. Then we're comparing fractions with the same denominator. Remember, you need to check using the different equal parts. Then you've got some word problems. There's also a challenge which will be on your home learning sheet. As I say, the challenge is not compulsory. Please upload your work to Seesaw and we will check it and let you know if there's any feedback. Thank you very much for listening, and I hope you have a great rest of the day.